In this session, we will cover the following topics. Features of size, feature control frames. So these are the feature control frames are represented in the drawing. So how we are going to use that one. Datums and datum feature symbol. So it means how the datums are being represented in the drawing. Datum placement, how we are going to place the datum symbols and attaching datum to the feature control frames. Selection of datums. That is point to be considered for selecting the datums and on what basis we need to select the datums. Basic dimension and geometric characteristics in the GD&T. So features of size. A feature of size is a feature whose physical size can vary due to the tolerances given in the drawing. So if you look into the below drawing, so you can see that there are few features like the slot is given and a hole is given. Hole is having a dimension of dia 30 and a tolerance is given. Similarly, for this slot, they have given 20 millimeters plus tolerance and minus tolerance. You can see in the 3D also the slot and hole. So we call these as a features. Why we are calling these as features is these can vary according to the tolerance which they have been given in the drawing. For example, this hole can be between 29.98 to 30.02 as per the dimension given in the drawing. So this is called as a feature of a size. Similarly, the width of the block and the length of the block can also vary depending on the size given in the drawing. Whereas the size, this side or this side individually cannot be considered as a feature of size, because this contributes to the other features. Like when you measure this surface and this surface thickness, you will get the length of this component, so which is going to be the feature of size, but individually the surface will not be a feature. So two more examples to see. Like if you look into this particular component, you can see the hole size is a feature, the OD of this cup is a feature, the small hole is going to be a feature, and this radius, the profile radius will be a feature, and thickness of this one is going to be a feature, and total height of this cup will be a feature. Similarly, in this plumber block, the bore will be a feature, the hole size will be a feature, the thickness will be a feature, the total length will be a feature. So feature control frames. A feature control frame is used to convey the geometric tolerance of a feature. So feature control frame, it is like a rectangular box which conveys some information to the person who is going to read the drawing. It conveys some geometric features or tolerances, many other requirements to the person who is going to interpret the drawing. So it consists of three zones. So first zone is called as the geometric characteristic zone, which will be consisting of symbols, and second one is called the geometric tolerance zone, which consists of the tolerance values with few more details, and the last section is called as the datum reference zone, so which mentions about the datum features. Now we'll come into the consideration of datums. So what is datum? A datum is a theoretically exact point, axis or plane from which the location or geometric characteristic of a part feature are established. For example, in this particular drawing, I can explain to you this particular face is made as a datum and they have given a dimension of 14 millimeter, which means that the hole position, the hole diameter 8 to 8.2 is given in the drawing. This particular hole need to be placed at a distance of 14 millimeter from the face C, which they have made it as a datum. So in this drawing, C is datum with respect to C, where your hole needs to be positioned. So like this, a datum can be established in the drawing. So we'll read this one in detail. So points you need to consider while selecting the datum. There are few points which you need to consider. For example, in this drawing you can see datum is considered here, datum A and datum B and datum C. So this bottom face is considered as A and side face is also considered as datum B and one more face is considered as datum C. So while selecting a datum, when you create a drawing or when you design a component, while selecting a datum, we need to consider few points. First thing is functional surfaces. What is the function of that particular surface which you are going to make it as a datum? It should be very, very important. Like function wise, it should serve some purpose and it should be very, very important for that particular component. And mating surfaces, like in the assembly, this particular component where it gets fitted. So if there is any mating between this particular component's feature or any surface is going to get mated in another component in the assembly, so that can be considered as a datum. And the datum should be readily accessible in the sense, in the manufacturing environment, once they manufacture the component, they need to measure it, they need to check the sizes, so it should be easily accessible for the quality engineer or the machine operator. Like, you know, in process inspection has been started nowadays. In the machine itself, they can check the dimensions. So at that time, the person who is going to run the machine should be easily accessible for him to that particular surface, so that he can easily measure the dimension. And surfaces of sufficient sizes to allow repeatable measurements, means you should have at least few minimum size should be there, so that we can check the dimensions at different positions. If it is a very slender thickness or very small feature, it will be very difficult for the inspector to check the dimension. So these are the points we need to consider while we decide what surface or what feature you are going to make it as a datum. And datum feature symbol. So how we are going to represent the datum feature in the drawing? So this is the symbol which is used universally. So it will be like the datum will be written as with a letter A, B. It starts with A, B, C, D, etc. And once you exhausted, there can be any n number of datums also. If you have exhausted with from A to Z, it will start with datum AA, datum AB, AC, like that. But 3 letters should not be used, that are I, O and Q. So these 3 are avoided in order to avoid the confusions. These 3 are not used to represent the datum. So it is consisting of a triangular symbol filled with a particular color and attached with a datum rectangular box. Inside the square box or rectangular box, you can have the datum symbol. In this particular drawing, you can see datums are mentioned. The OD of this particular feature is made as datum A, and the OD of the other feature is made as datum B, and the face of this feature is made as datum C. Datum placement on plane surfaces. Like if we need to create any datum features, datum symbols on a feature like this, like a cube or a rectangular surface where you need to keep the datum symbols. Like in this case, you can see you can place the datum symbol directly on the surface. So datum A is directly placed on the surface. The next choice is you can place it over the extension line, which is used for the dimension also. But main thing which you need to keep it in mind is it should not be in the same line. It should not be aligned along with the dimension line. There should be a clear space. The clear space should be maintained between the datum symbol and the dimension line. This point we need to keep it in mind while placing the datum on a planar surfaces. Datum placement on size features. Suppose if I am going to place a datum on a size feature, that is the feature of size, like a cylinder or anything like that one. So we can use this kind of method where we are going to place the datum aligned. It should be aligned along with the dimension line itself. So you can see datum A and datum B in the top drawing is aligned along with the dimension line, or in the below drawing you can see for a diametrical symbol it is aligned, or it can be placed directly on the surface also, but it should be aligned. So the main difference between the datum placement on features of size and surfaces, in surface it should not be aligned, and on the size features it should be in line along with the dimension line. So these are the main difference between the datum placement. Attaching datums to feature control frames. So as we discussed earlier about the feature control frame, so it is a rectangular block which is going to convey few information to the person who is going to interpret the drawing. So this is a wrong way of placing datum to the feature control frame. Here you can see the datum is not at all connected to the feature control frame. Feature control frame is somewhere here and datum is at a different location. So this is not a correct way. It will make your drawing to look unorganized, or it will be very difficult to interpret. So the correct way of attaching the datums to feature control frame is this method. So the feature control frame is here. You can attach it to the bottom or to the top using a normal datum symbol representation method. Use the triangle and use the square box to include the datum letters here. So this will make your drawing to look very clear, and it will avoid the ambiguity, and proper interpretation of the drawing can be done if we use this kind of representations. And now we are coming to the selection of datums. So if you look into this example drawing, so the datum is selected like this. Datum A is taken as the OD. You can consider this feature as diameter. So OD 65 is considered as datum A, and this face is made a datum H. You can see here they have given one more control tolerance here, and they have made a datum feature attachment here. And the main important point is they are going to relate the datum with respect to A and H will be related to this feature, the detail AJ. If you see in the next slide, the detail AJ, it will take the reference of the previous datum to the new drawing also. For example, this is the original drawing, and they have given a detailed drawing AJ as further detail they have given here. In this, instead of making the datum A and H to carry here, what they have done is they have made this diameter 115 as a new datum J, but the relationship between this particular feature and the original feature has made here like this. H and A, they have connected here. H and A is being taken into a feature control symbol, and the relationship is being established here. And in this drawing, the further this datum J is used for the further features. You can see in two more locations they have related. So this is one way of representing the datums. And next, main thing is during the assembly we need to use corresponding features on mating parts to establish datum. So this will be very helpful for us, and as well as for the person who is going to use the drawing for mating or use the drawing for the assembly. It will be very helpful. If you look into the drawing, you can see the axis of this feature and axis of this feature is controlled by the datum A. So both are same, so they have given datum A and A, and this bottom face is taken as datum B, which is going to get mated to this bottom face, and this is also represented as B. So during assembly it will give the clear picture for the operator or the person who is going to assemble, and he will make sure that datum A aligns to the datum A and datum B gets mated to the datum B. So I'll just show you one image, a small simulation movie, so that you can understand how this will be helpful. See, in this one you can understand the magenta color part gets assembled to the green color part. Since we have placed the datum to this bottom feature and the bottom feature of the magenta, the operator will not get confused, and he will assemble it and make sure that this datum feature B is getting mated with this datum feature B of the green color part. If you don't give the datum feature as B and B, operator will be confused, and there is a chance that he may assemble it 50%, like it will not go until the bottom, and he may stop it like this also. But since we have given the datum A and datum B properly in both the mating elements, it ensures that you are able to properly mate this part and get properly aligned without any confusion. Again, you can look into this video, you can see how it gets aligned properly. It goes till the bottom. It stops till the bottom. So it stops at the bottom only, and it made sure that it is aligned. So this is the advantage of using the datum, corresponding datum symbols on the mating parts. Now we will come to the topic basic dimension. So it's going to be very interesting from now onwards, because it's going to be dealing detail with the GD&Ts and few more features also. So what is a basic dimension? A basic dimension is a numerical value used to describe the theoretically exact size, profile, orientation or location of a part feature. For example, in this drawing you can see it is in the rectangular block. Normally basic dimensions will be represented within a rectangular block. So whatever dimensions are coming within a rectangular block are considered as basic dimension. Since it is coming inside the rectangular block and no tolerance is given, you need not have to consider that it doesn't have a tolerance. It has tolerance, but it is given in the feature control frame. To explain about this drawing, this diameter 10 hole need to be located within a tolerance of 0.015, and this 0.015 is the positional tolerance for these two dimensions, the basic dimension. So now we will see the advantages or benefits of using the basic dimensions in a drawing. If you look into this drawing, so the dimensions 60 and 61, they are all not basic dimensions since they are not within the rectangular box, whereas the dimension 20, 50 and this 20 and this 20, they are all coming within the rectangular blocks. So they are considered as basic dimension. We will see the advantages. What will happen if we use a basic dimension to position these holes, and if we don't use a basic dimension to position these holes. First we will see, if we don't use a basic dimension to position these 4 holes, what will happen. So in this case, I have not used the basic dimension. Instead, I have used the common normal dimensioning method as the plus or minus tolerances. So here the whole dimension is given, the position is given as 20 plus or minus 0.003. Similarly, in the x-axis it is given, and the pitch distance between first hole and the second hole is also given as plus or minus 0.003. The main disadvantage or the drawback of using this kind of dimension is tolerances zone for the secondary holes are located from actual position of primary hole, allowing a tolerance stack up related to the surface that the primary hole is located. So what they are trying to say in this diagram is, if you look into this hole, the first hole will be positioned within a tolerance zone of 20 plus or minus 0.003 millimeter from the reference surface A. And the second hole dimension will be depending on where you are going to place the first hole. From the first hole's location, the second hole will be varying within a dimension of 20 plus or minus 0.003. Because of this, there is a additional tolerance stack build up, and the second hole position will not be properly aligned with respect to the datum A. So the total dimension of 40 millimeter cannot be maintained properly within the required tolerance. So this is the drawback. So if we go with the normal basic dimensioning, what the advantage is, the zone will be fixed and it is not influenced by the actual location of previous hole. Since the hole positions, the first hole positions dimension is given as 20 as basic, and the hole to hole distance is also given as 20, and it is a basic dimension, wherever you are going to place the first hole, the second hole will not depend on the previous hole, and your second hole dimension from the reference plane will be always 40 plus or minus the tolerance given in the feature control frame. So this is the main advantage of using basic dimensions in a drawing. So according to the applications, we can use wherever required to give a better control for our component. Now we will go to the next topic, geometric characteristics. So in the feature control frame, we found that there are 3 zones. First zone is called as geometric characteristic zone, and second zone was geometric tolerance zone, and third one is the datum reference zone. Now we will deal in detail about the geometric characteristics zone. So when we tell about the geometric characteristics, there are totally 5 categories which include the 14 geometric characteristics totally. So 5 categories includes 14 symbols, 14 different geometric characteristics and symbols. So to easily remember the 5 categories, we have developed a concept called as FOR-PL, F-O-R-P-L. So each letter has one expansion. So I'll tell you in detail about it. So if you remember this FOR-PL, so you will be thorough about the GD&T. For F for form tolerances. Under form tolerance, we have 4 different tolerance characters, 4 different geometric characteristics. And O for orientation tolerances. And under orientation, you have 3. And R for runout tolerances, and under runout you have 2 categories. And P for profile tolerances. Under profile tolerance you have 2 different tolerances. And lastly L for location tolerances. Under location tolerance you have 3 different tolerances or 3 different geometric characteristics. So to conclude, FOR-PL is the easy remembering word for form tolerance, orientation tolerance, runout tolerance, profile tolerance and location tolerances. Under form tolerance, we are going to see 4 geometric characteristics or the geometric symbols. They are flatness, straightness, circularity and cylindricity. So flatness, just to give a brief idea, flatness means any feature you are mentioning, it should be flat. That's it. And straightness, again same, the feature which you are going to refer, it should be straight. So you can see in this drawing, this is a feature which they are asking need to be straight and giving a value of 0.1, which means that this surface should be straight and it should be within this tolerance zone. Circularity, it means that the section should be circular. The feature which you are going to tell should be a circular and it should be within a given tolerance zone. And the cylindricity, the basic difference between circularity and cylindricity is circularity defines the cross sections, only one section it will be defining, whereas cylinder for the whole feature. Throughout the length, it needs to be a uniform cylinder. So that's what it says. So these four characteristics form the form tolerance. Next one, orientation tolerances. In orientation tolerances, we have three categories. They are perpendicularity, angularity, and parallelism. So these three geometric characteristics or symbols constitute the orientation tolerances. So perpendicularity, it defines about the perpendicularity between one feature to the another. With respect to one feature, how the other feature should be perpendicular. And angularity, similar to perpendicularity, other than 90 degree, it's called as the angularity. 40 degree, 30 degree, 45 degree, anything. So those degrees should be varying within that value. They are called as the angularity. And parallelism, so similar to that flatness or straightness, it's parallelism with respect to one more surface. In parallelism, the main difference is for flatness, we are not giving any reference. We say it should be flat, but parallelity, we need to say with respect to what it should be parallel. So a datum is required in this case. So we will deal all these things in details. And runout tolerance. So in the third letter is R. So runout tolerance. Under runout, we have two different types. One is circular runout and total runout. It is like cylindricity and circularity. So circular runout is like one cross section will be taken and it should be circular in that cross section, and total runout is taken throughout the feature, throughout the surface. It should be it should be controlled. Fourth letter is the P for profile tolerance. We have two categories or two geometric characteristics. They are profile of a surface and profile of a line. It defines about the surface's feature, like a profile, how it should be with respect to what, and profile of a line is like a 2D and it is like a overall surface. And the last one is the location tolerance. So location tolerance is the last letter in the 4PL. So we have three geometric characteristics. They are position, concentricity, and symmetry. So position is telling about where your feature needs to be with respect to some datum or something, where it needs to be, the actual position, where it is located. And concentricity. So with respect to one datum, it should be concentric, two centers. You can see here the small hole and the bigger hole is given. So this will be a datum axis. So the small feature should be concentric with the bigger feature, like that concentricity is explained. And symmetry. So when they cut, the cross section should be symmetrical in both the sides. For example, if you cut this cube, it will be symmetrical on both the sides. So how much it can vary symmetrically. So that is called as the symmetric geometric characteristics. So this is about a brief idea about the different characteristics. So to summarize the 4PL, you can see what are the features. So under form, we have four geometric characteristics. They are straightness, flatness, circularity, and cylindricity. Under orientation, you have three. They are parallelism, perpendicularity, and angularity. Under runout, we have two, circular runout and total runout. Under profile, you have profile of surface and profile of line. And finally, we have the location tolerance. Under location tolerance, you have concentricity, position, and symmetry. So these are the three geometric characteristics under location. To summarize, totally 5 categories we have. Under the 5 categories put together, we have 14 geometric characteristics which form the geometric characteristics in GD&T. So this is about a brief idea. In the further sessions, we will be seeing all these geometric features in a detailed manner. Thank you.